Hi guys, this is exercise 2A debrief for question 15. So this is the infamous question that a lot of you struggle with, given that alpha is the root of the equation x squared minus 2x plus 5 equals to 0. Show that 2 alpha cubed plus alpha squared plus 25 equals to 0. And part 2, alpha to the power 4 is equivalent to 5 minus 12 alpha. Now, the main concept behind this question is targeting at this statement. Alpha is the root of the equation x squared minus 2x plus 5 equals to 0. What does this mean? This means that alpha is actually the solution of the equation x squared minus 2x plus 5 equals to 0, which means that if I were to substitute alpha into this equation here, okay, I can get this relationship. Alpha squared minus 2 alpha plus 5 is 0. So the thing behind proving questions is that you always start somewhere and you try to get somewhere. Okay, so this is the solutions for part 1. Alright, so we start with this particular relationship that we have derived earlier. So we start with this. Alpha squared minus 2 alpha plus 5 is equals to 0. Now, the reason why I named the equation 1 and I started is because this is a very important step that you need to take note of. Alright, so when I look at what I have and I need to get to what I want, a wise move to make would be to multiply 2 alpha throughout. And so that is what I did. So when I multiplied 2 alpha to every term, this is the expression that I get. So I get 2 alpha cubed minus 4 alpha squared plus 10 alpha equals to 0. Now, if you're uncomfortable with just multiplying 2 alpha to each term and writing each term down, you can always write 2 alpha in front of this term first bracket and slowly expand. But this is the statement you should get. Okay, so from 1, okay, but before we go there, you realize that I am quite close to my statement, but not that close. Why? Because my statement does not have any term with 10 alpha. So what I want to do is to get rid of the 10 alpha. And how do I do that? I come back to the relationship that I have here in part 1. So from part 1, we have alpha squared plus 2 alpha equals to 2 alpha. This is not too fancy. What I did was to, my aim here is to try and express 10 alpha in terms of something squared. Okay, in terms from statement 1. Okay, so what I did was to just bring add 2 alpha on both sides from part 1. Okay, switched it over. 2 alpha equals to alpha squared plus 5. And then I found this particular relationship. 10 alpha is actually equivalent to 5 alpha squared plus 25. So essentially what I did was to substitute 10 alpha. I want to find 10 alpha in terms of alpha squared so that I can continue expressing this expression in terms of to get what I want. So I substitute 10 alpha equals to 5 alpha squared plus 25 into part 2, which is what I found so far in this particular relationship. And then I get this 2 alpha cubed minus 4 alpha squared plus 5 alpha squared plus 25 equals to 0. By simplifying it, I can get what I want. Okay, so this is for part 1. Alright, okay, now let's move on to part 2. Part 2 wants me to show this relationship. Okay, once again, we start with what we have. So starting with what we have from equation 1. So one wise move to do is actually to multiply alpha squared throughout. I'll leave that as an exercise for you guys, but for the purposes of this video, I will show you a much shorter way. Okay, so from part 1, I get alpha squared is equals to 2 alpha minus 5. Okay, instead of multiplying alpha squared to every term, what I can do is to square both sides. So I get alpha squared squared equals to 2 alpha minus 5 squared. And then I get alpha 4, alpha to the power 4 is equivalent to 4 alpha squared minus 20 alpha plus 25. This is simply making use of your a minus b everything squared expansion. Okay, but as you see from this statement to this statement, what I need to do is to get rid of this 4 alpha squared term. So what I can do is once again use this relationship here. Okay, I am going to use this relationship to substitute 4 alpha squared away. So you see 4 alpha squared is actually just 4 times 2 alpha minus 5. Okay, equals minus 20 alpha plus 25. I get, by simplifying this, I get 8 alpha minus 20 alpha plus 25. And when I simplify it, I get what I want. Alright, so I hope these two exercises have given you a better idea of what it means to start with what you have in order to get what you know. Thank you.